a Portland Community College mathematics telecourse. A course in arithmetic review, produced at Portland Community College. After the last lesson, I hope you begin to realize what my friend said by the statement percent is a tally unit in all of business. In this lesson, we wish to try to tackle problems that become more involved in their wording. In the last lesson, we tackled simple statements of the form what is what percent of what. That's going to be our secret. Now that hopefully we're good at that type of problem, if a problem becomes more involved, we'll try to restate it like this. Let's look at this problem. A business loan charges simple interest at a rate of 9.5% per year. The interest for the first year was $4,658. What was the amount of loan? See, in this problem we have 3 sentences. Our problem is one of semantics, not mathematics at first. Can we restate what we want in terms of what we have in one simple sentence? Reread this again. Now, can you see that this is saying the same thing as this simple statement? 9.5% of how much is $46.58. Now, clearly, there's no problem that we have 9.5%. The interest for the first year was this, so we're taking 9.5% of something. Well, that's what I don't know. But they told me the interest is this. Now, this is more a matter of you knowing your language quite well or your business quite well. But in any case, be able to translate it to a simple statement. That's not easy, but realize that's not mathematics either. That's a matter between you and your language. But once we have the simple statement, we may choose either method 1 or method 2. Let's use method 1, the translation method. 9.5% is 0.095. The of is times. And the how much translates to my unknown, in this case the amount. And the is translates to equal, and the 46.58 is already mathematics. And we have a simple sentence where we recognize that to undo multiplication, we divide both sides by the multiplier of the unknown. So now our sentence says that A is 46.58 divided by 0.095, which is $49,031.58. The secret was to try to get this simple statement of our problem. Let's try another one. The population of a town this year is 14,100. Last year it was 11,750. This year's population is what percent of last year's? In this problem, many times they do that. They do restate your problem in one simple sentence, but they use words where they could have used numbers. Watch this now. This year's population is simply 14,100. They told me so, so I simply replaced this 3-word phrase with the number that's equal to it. And the word is, of course, is equal. And the word what is my unknown, and I'll call it P since they're telling me they want percent. But the word percent means times 0.01. The word of means times. And last year's population, they told me that it was 11,750. Now that we have a simple sentence, we can solve it. In this case, doing this portion first, we get 117.5 times P. Again, we recognize that the unknown is being multiplied, and to undo multiplication, we divide. So this says my percent is this divided by this. Doing that, we get 120. And of course, that's percent, so this word simply can be written that way. That has nothing to do with moving the decimal point. We have simply written this word by this symbol. Now remember, 100% means all of. So this is more than 100%, so it must be more than all of. And last year we had 11,000, so now we must have more than all of that. And 14,000 is somewhat more than 11,000. So at least we're in the ballpark. But again, the secret was to see this simple statement of the problem and recognize that the words could have been replaced by numbers. Let's try another one. If there is a 4.2% sales tax on a $560 kitchen range, how much is the tax? Now, can you restate that problem as a simpler statement? How about this? Isn't that what they really want to know? What is 4.2% of $560? Now translate. What is my unknown? Is equal 4.2%. If I want to get away from a percent, I move it 2 places away, which gives me 0.042 of is times 560. And see, in this case, it's telling us exactly what to do. My unknown is that number times that number, which is $23.52. Again, the secret lay in our being able to state in a simple sentence what the original person stated in more words. Now in this problem, they did once again state the simple sentence for us if we can see it. The Bellevue High School basketball team won 15 games and lost 3. What percent of its games did it win? To the nearest whole percent. Now, can you find the simple sentence of the problem there? There it is. Now let's begin to translate that word by word. The what is my unknown. Percent means times 0.01. Of means times. Its games, now don't let that fool you. Its games, all of its game is not 15 and 3, but it won 15, lost 3, so its games was a total of 18 games. Now again, don't let this phrase fool you. Did is a past tense of the word is, so that's equals. And win, well, that's the 15 games. So what percent of total games was the wins? Once you get used to it, it's really very simple. And now it's simply a matter of solving a simple equation. Doing the indicated multiplication we get, dividing both sides by the multiplier of the unknown we get, and carrying out the indicated division we get 83.3333, but the problem stated to the nearest whole percent, and here's the whole. This is less than 5, so I'll round it down. Now when you're using one of these two methods, method 1 or method 2, when the problem is asking for a percent, when you're done, you're absolutely done. If you wish to say this as a percent, then simply stick the percent sign on. This is simply our way of saying the word percent, which was in our sentence, that's all. But the answer is 83 of those percents. Now many students become quite frustrated over these types of problems. Know that most of your frustration will lie with language, not mathematics. Knowing this, don't ask, how do I do it? Before you have asked yourself and answered the question, what are they saying? Then say the same thing more simply. Let me illustrate this. typical statement you might hear. A storage depot raised all of its rental rates 8% over last year's. If an annual rent was $240 this year, what was its rent last year? Now see, as it's stating, that's quite a few words. Now let's state it differently. This year's rent is 100% of last year's rent. Can you see that saying the same thing? Last year's rent is 100% of itself, but we raised it another 8%, so it's 100 plus 8. Now seeing that was a little bit tricky, but that's language. But in this case, which of these do we know? This year's rent or last year's rent? So in rereading the problem, it's this year's rent they told us. It's last year's rent we don't know. So this year's rent can be replaced by 240 because they told us. Last year's, that's my unknown. Now translating this, 240 is 108% of X. We get this. And this is easy. See, this is the pure mathematics. In fact, the only spot that we have pure math. And we can just look at that and make the simple decision to divide both sides by 1.08. Do the arithmetic on the calculator, and we're done. And the rent last year was indeed less than this year's. This spot here is the pure math. This is arithmetic. This translation really is still not half bad. 240 is 108% changed into a decimal of last year's. So that's easy. So where was the problem? In going from many words to few words. And that's found by asking, what are they saying? And somehow saying the same thing more simply. So this is where you must focus your attention on these problems. If you do so, it becomes fairly easy. Asking how do I do it won't help you until you have first answered this. Let's work another problem pretty much like that one to see if we can identify some commonality, something about the wording that will give us a clue. Let's see, a newspaper states that the town's current population is 14,600, which is a 7% increase over last year's population. What was last year's population? There's a tendency at first to want to take 7% of this, then subtract it. But then we would be taking 7% of the current one, when this clearly says that it's increasing 7% over last year's. So if anything, we should take 7% of last year's, which we don't even know. So how can we do something we don't know? So since our difficulty is here, it's best that we stop here and realize that nowhere does it say that I want to take 7% of this. This says, in fact, I want to increase it by 7%. Now, recall this from our beginning of studying of percents. Whenever we use the word all of or the same as, then you have 100% of something. Therefore, if the population stayed the same as, again that word same as, it would be 100% of what it was. Let's call it L for last year's population. If we had said 8% of, then this is certainly a great deal less, isn't it? But this says I want to increase. So it's going to have to increase above 100%. It's going to increase 7% above 100%. So with that kind of thinking, somewhere along the line you have to see this, that this year's population is in fact 107% of last year's population. Last year's population, of course, is 100% of itself. And you can see I took what it was in itself and increased it 7% to give me that 107%. Are you beginning to see that? It's like speaking any language. You must speak it and try to see it 2 or 3 or 4 times, and finally it begins to dawn upon you. But then as soon as you've been able to state this, you have the simple is percent of sentence, and you can begin to replace words by numbers. This year's population. Do we know that? Well, it says that the current population this year's is 14,600. So this year's population is 14,600, is 107% of last year's population, but that's what I don't know. So let's use a letter for that. So now we have our simpler is percent of sentence, and we can go to whichever method you prefer, the translation or the is of. If we're using the is of relationship, we see that 14,600 is attached to the is, 107 is attached to the percent, and L is attached to the of, which I don't know. Now, either by calculator or by hand, we simply solve this proportion. So 14,600 times 100, divide by 107 equals, and we have, and of course populations doesn't allow us to have fractional people, so we'll round this off to the nearest whole person, which is 13,645. 13,645. And indeed, last year's population is less than this year's, as we say it should be. If we were to find the increase now just as a check, if we were to subtract these two, we would get 5, 5, 9. So we actually increased the population by 955. So we could ask this question now. Let's look at our increase. Our increase, 955, is what percent of what it increased from? And it's increasing from this, going towards that. Now we're doing this just to check that our thinking is reasonable about what we've just finished. Okay, now translating this to our is of situation again. The 955 is attached to the is. The what is attached to the percent. The 13,645 is attached to the of. And of course this stays at 100. Now working this problem, we get 955 times 100 divided by 13,645, and we get, in fact, rounded off to the nearest whole percent, 7%. So our increase, which was actually 955, was indeed, to the nearest whole percent, 7% of my, or over my last year's population. Actually, in business math, and later in algebra, we will allow you yet a third way of solving this, which will allow you to go from the words to algebra more quickly. But in order to do this, your instructor will first have to teach you some algebra above and beyond what you've learned in this course. So if you're using only the knowledge taught in this course, then at this stage of such problems, you must recognize that you're going to have a reading problem, and try to approach your problem from that point of view. Reading. What are they saying? Can I say it in a simpler manner? And if they're increasing something, you must realize that what are you increasing? If you're increasing it over what it was, then anything is 100% of what it is. If you increase it another 7%, then it's now going to be what it was, that's 100%. increased by another 7% or 107%. Does that help you just a little bit to get a feel for the real problem? And that is, what are they saying? Let's spend a few moments and just peek ahead into algebra so that perhaps you can see why one would even want to take such a course. Let me redo this problem as an algebra student might do it. And don't worry about if you can't follow the algebraic manipulation because, of course, you haven't had it yet. But see if you can see how easy it is to translate from this English statement into an algebra statement, even with the little background we have at this point. Now let's take into account the entire longer sentence or two and ask ourselves, what are they really saying in total, and say it in algebra? Well, we're saying that last year's population increased by 7%, and see that's 7% as math, of last year's population will give this year's population, which is 14,600. Now back here, if I have last year's population, that's the same thing, isn't it, as 1 times last year. So you'll learn in algebra that if I have something like this, 5 of last year's increased by 2 of last year's, well, you can see then I have not 7, I have 7 of last year's. So you'll learn that if I have one variable L here plus 0.07 L, then grand total I have 1.07 of last year's. Now this process of going from here to here in algebra you would call combining like terms, and I don't expect you to necessarily follow me comfortably, but at least you can get the flavor of it. But at this point you can see that to undo multiplying, I divide both sides by 1.07, and doing that division I get exactly what we had earlier, 13,000 some odd. But you see how easy it is to restate this now using a broader aspect of algebra than we've allowed ourselves yet? Simply 1 of last year, or all of last year's population, increased by 7% of last year's is this year's, which is 14,600. So with a little bit of algebra, this type problem will indeed become easier for you in the future. So do look forward to taking algebra shortly after this course. It will certainly pay off. Because this type of problem is really a matter of experience, and much experience at that, this particular lesson will start with fairly simple problems, somewhat more complicated than the last one, but not as messy perhaps as you would find in a business or accounting course. So let's try this one. The Cooper's house is valued at $72,000 and rents for $600 per month. What percent of the value of the house is the annual rent? Very often, if you're reading carefully, when you get to the point where they're asking you for something, you find that already is a percent of an is. So let's begin to read this very carefully and see which of its words we can replace by numbers from the previous sentence or sentences. So it says, what percent of the value of the house? Well, the value of the house we know. So this entire phrase here, value of the house, we know that's $72,000. Now what else is there that we might know? Okay, is the annual rent. Well, I don't know the annual rent, I know the monthly rent. But annual means per year, so if I were to take 6 times 12, I would get 7,200. So now let's see what we have. What percent of is times the value of the house, 72,000, is equal the annual rent, which is 7,200. And now doing this arithmetic, for the simple reason I can do it, I get 720 times P, and then undoing the multiplication by division, I finally get that P is 10, and of course that's percent. So they're paying 10% of their annual per year. They're paying 10% of the value of the house in rent. Within this homework assignment, do look for simple sentences within the total complex of the problem where it is an of is percent problem. Then you simply identify the nouns and objects of the sentence. Try to replace them by numbers if they're possible. And if it's not possible, replace it by a variable, then translate it and solve it. Again, we need to emphasize this will take a bit of practice and will entail a fair amount of frustration. But bear with it. It comes with experience. Now, summarizing what we've just been doing, when you see a complicated or a series of sentences explaining your problem, the first thing you try to do, try to locate a simple is of percent sentence and replace words or phrases by numbers from the rest of the problem. And then, of course, translate them into algebra, where it will usually be a simple algebraic sentence or a proportion. And of course, if you can't locate that simple is percent of sentence, then you must be the one to restate that problem in a simple is percent of sentence. And therein is going to lie your problem. And know that that's a matter of your own personal use of language and your own ability to see what is being said in a written page. This is your math host, Bob Fennell. Good luck.